In this lecture, I would like to discuss something called discrete random variables. To do that, I will start with a quick introduction. After this, I will move to probability distribution, which is used for describing discrete random variables. After this, I will move to the expected value. So how expected values or mean values are estimated based on the information we have about probability distribution. And after this, I will finish with the discussion of three discrete random variables: binomial, Poisson, and hypergeometric. So let's move to the introduction. So a random variable, this is a variable that assumes numerical values associated with the random outcomes of an experiment, where one numerical value is assigned to each sample point. To understand this term better, let's have a look at the example. Suppose we toss two coins simultaneously. So this is the example that we've seen in the previous lecture. So we know that the sample space of this experiment consists of 4 sample points: 2 heads, 2 tails, first head, second tail, first tail, second head. And for example, we might ask the question, what is the probability that we observe some number of heads? And in this case, a random variable is the total number of heads observed in 2 tosses of a coin. And given the sample space, we can see that random variable can be either equal to 0 in case of tail, can be equal to 1 in case of HT and TH, and it can be equal to 2 in case of HH. What you need to know is that there are 2 types of random variables: discrete random variables, and this lecture is about those type of variables, and in the next lecture I will discuss continuous random variables. So a discrete variable is a random variable that assumes a countable number of values. And here are some examples for you. For example, the number of seizures an epileptic patient has in a given week. So the value can be from 0 to whatever number. Another example could be the number of voters in a sample of 500 who favor impeachment of the president. And for example, the random variable can be equal to 0 and all the way to, let's say, 500. And one more example is the number of customers waiting to be served in a restaurant at a particular time. So once again, a random variable can be equal to 0, 1, 2, and all the way to some value. As for continuous variables, those are random variables that assume values corresponding to any of the points contained in an interval. So a continuous variable will always have some sort of interval, either time interval, maybe some volume, maybe some area. So, and some examples are in front of you. So the length of time, let's say in seconds, between arrivals at the hospital clinic. And in this case, the random variable x can lie between 0 to infinity. Another example of a continuous variable could be the length of time, let's say in minutes, it takes a student to complete a 1-hour exam. And in this case, the random variable can be any value from 0 to 60. And one more example is the weight, let's say in pounds, of a food item bought in a supermarket. And in this case, a random variable can be any value lying from 0 to 500.